Hi guys, welcome back. From this video onwards, we are going to discuss new topic called BEEE. In some of the colleges, the same subject is also known as BEEE. Basically, BEEE in the sense it only discusses about electronic subjects, but in this course, we are going to discuss about both the basics of electrical and electronics engineering. In this subject, we have three subjects related to electrical and two subjects are related to electronics. I'm starting off with diodes and transistors. These are the basic subjects related to electronic subjects. First of all, we are going to discuss about PN junction diode. What is PN junction diode and its biasing? What are the applications of PN junction diodes? From that, we will continue our discussion on transistors, different types of transistors, and we will mainly focus on bipolar junction transistors only. We won't consider unipolar transistors because that's what the things are in subject syllabus which was given to me. Yeah. Then let's just start this topic. PN junction diode. What is meant by PN junction diode? First of all, we have to know what is this PN signifies. PN junction diode means in PN junction, these are made up of two types of semiconductors. These are combination. This type of diode is combination of two what we call type of semiconductors. One is P-type semiconductor and another is N-type semiconductor. And we will dope both of them and we will form PN junction diode. Just don't ask what is meant by P-type and N-type. There is a big theory related to it. Just by heart the thing that P signifies positive ions and N signifies negative ions. P in the sense positive, N in the sense negative. Because the word itself signifies P positive and negative. It's very easy to remember in this way. Okay, this is the basic info about PN junction diode. What is the function of PN junction diode? Diodes allow electricity to flow only in one direction. The allow circuit symbol shows the direction of current. Just look at this circuit symbol. This symbol signifies that the current will flow only in this direction. The reverse flow of current is not possible. Strictly speaking, the reverse flow is also possible, but under certain conditions. The basic function of the diodes are used to flow current only in one direction. And when we are discussing about diodes, we have to know about two things. One is forward voltage drop and another is reverse voltage drop. Forward voltage drop in the sense when the diode is what we call applied forward voltage, then okay, I will read the things. When forward voltage is applied to a diode, a small voltage experience across a conducting diode. It is called the forward voltage drop. And it's about 0.7 voltage for normal diodes, which are made from silicon. The forward voltage drop of a diode is almost constant, whatever the current passing through the diode. So they have very strict current voltage drop. That is the sense. As we discussed, these diodes will allow current in only one direction, right? We need the current flow to be in only in forward direction. So whenever we apply a small voltage across this diode, that means it ranges between 0.3 to 0.7 voltage. Actually, it changes from type of diode to it changes from doping capacity of an semiconductor. Okay. At most we can have 0.7 voltage and at least we are going to have 0.3 voltage. If you are going to apply this small voltage, that's it. The current starts flowing immediately. It's going to like this peeper. Whatever may be the what we call current flow, the voltage will be stays constant. That is the characteristic of an diode. In reverse voltage, yeah, I said right. If we speak to be frank, the current will flow in reverse direction also under certain conditions. Just look at that condition. When a reverse voltage is applied, a perfect diode does not connect. See, a perfect diode does not connect. But all real diodes leak a very tiny current of few microamperes or less. This can be ignored in most circuit because it's very much smaller than the current flow in the forward bias. However, all diodes have maximum reverse voltage of usually 750 volts or more, and this exceeded the diode will fail and pass large current in reverse direction. This is also called as breakdown. Yeah. If you are going to apply large voltages in the reverse direction, that in the sense, when compared to 0.7, much greater than 0.7, that in the sense 50 to 70 volts. This is the range of an what we call typical diode. If you are going to apply this much of voltage in a reverse direction across an diode, then it's going to be breakdown and it will pass a large current in the reverse direction, which is also known as short circuiting of an diode. That means it breaks down. It cannot be reused. That is the basic intro about forward drop voltage and reverse voltage. Now we will discuss where we use these junction diodes. Ordinary diodes can be split into two types: signal diodes, which passes only small currents in signaling and processing, and rectifier diodes, which passes large currents. We have two types of diodes. One is signal diode, another is rectifier diode. In addition, there are other types of diodes such as LED, xenodiodes, tunnel diodes. These all things are what we call. These are suppliers of these diodes itself, and these diodes are particularly deals with one type of things only. If we consider LED, it deals with emitting of light itself. That's it. Xenodiode, in the sense, which helps in regulation of reverse voltage. Every diode mentioned here is basically used for certain purpose, but these are the broad classes: signal diodes and rectifier diodes. Now we will discuss about this what is meant by signal diodes and what is meant by rectifier diodes. Signal diodes, in a sense, just remember small currents. Signal diodes are used to process information, electrical signals in the circuits. So they are required to pass only small current up to 10 milliamperes. Signal diodes can only pass up to signal diodes can only pass up to 100 milliamperes. Just mark in. Remember this. General purpose signal diodes such as this is a typical type of signal diode, and we have some nomenclature for that diodes also, which is not a part of this syllabus. 1N4148 are made from silicon and have forward voltage drop of 0.7 volt. As discussed, right? It's going to be range from forward voltage drop is going to be range from 0.3 voltage to 0.7 voltage. Yeah. This is one of the type of signal diode, and the main purpose of signal diode is to pass the current less than 10 milliamperes. Just remember this. Germany diodes, and these are also non-rectifier diodes, such as 0A90 have forward bias voltage drop of 0.2 voltage. It's actually 0.3 voltage. I don't know why they mentioned 0.2. For Germany diodes, actually the forward voltage is 0.3, which is the least voltage. If it's purely germanium, I think it's some other alloy. I think it makes them suitable to use in radio circuits, such as detectors, which extract audio signals from weak radio signals. Audio from extract the audio from weak radio signals. If you want to extract video from, audio from weak radio signals, it has to rectify its what we call amplify, amplify the signal wavelength or some other parameters. In this type of things, we use germanium diodes. These are also known as rectifier diodes. For general use, where the size of forward voltage drop is less important, silicon diodes are better because they are less easily damaged by heat when soldering. They have lower resistance when connecting, and they have very low leakage currents when reverse voltage is applied. It's an extra point. We will prefer silicon diodes moreover than germanium diodes because the forward voltage drop is very low for germanium diodes when compared to silicon diodes. And silicon diodes also, like, they can resist some reverse voltage much greater than germanium diodes. That's why we basically use silicon diodes. That's what it mentioned. Yeah, this is up to this video, and I think I gave an sufficient information regarding PN junction diode. Okay, guys, thank you. Meet you in next video.